Deep in the freezing expanse beyond the reach of any warming sun, two small constructs of metal and ambition drift through the absolute zero of the interstellar medium. These are the Voyagers, twin messengers forged from aluminum, copper and gold, cast out from a pale blue world in the year 1977. They move at speeds that would shatter any terrestrial vessel, yet in the context of the galactic scale, they are effectively frozen, crawling through a lightless ocean. On their flanks they carry a golden record, a disc of copper plated in the most noble of metals, etched with the sounds of a heartbeat, the laughter of a child, and the intricate mathematics of a pulsar map. This is our first physical letter, a testament to a species that dared to believe it was not alone. The vacuum through which they travel is not merely empty, it is a profound and heavy nothingness where the temperature hovers a mere 3 degrees above the absolute cessation of all molecular motion. Here the Voyagers are the only evidence that chemistry ever organised itself into consciousness in this corner of the void. While these physical artefacts crawl through the dark, another message outpaces them by a factor of thousands. Since the early decades of the 20th century, a sphere of electromagnetic radiation has been expanding outward from our planet at the speed of light. It is an invisible ghost of our existence, a bubble of energy composed of early television broadcasts, rhythmic radar pulses, and the frantic digital chatter of a global civilization. This sphere is now more than 200 light-years across, a shimmering ghost shell of human history washing over the nearby stars. To an observer with the right technological eyes, Earth would appear as a sudden, brilliant flash in the radio spectrum, a spark ignited in a dark room that has been silent for billions of years. This sphere of light screams our coordinates and our nature into the abyss, a second letter written in the fundamental language of physics, expanding at nearly 300,000 kilometers per second into the unknown. This effort is a bottle cast into a sea of ink. The parchment inside is crowded with our names, our music, and our desperate hope for recognition. We have thrown this bottle into the currents of the Milky Way, watching it bob on the surface of an infinite lightless tide. For over a century we have stared at the horizon of the cosmos, building massive ears of steel and silicon to catch even the faintest whisper of a reply. We have pointed our arrays toward the thickest clusters of stars, toward the galactic centre where the density of suns suggests a higher probability of companionship. We have waited for a ripple, a glint of reflected light, or a hand to reach out from the shadows and pull our message from the drift. We have listened for the rhythmic pulse of an artificial beacon, or the messy spill of another world's radio history. But the response is a deafening mathematical silence. The stars do not speak. The radio waves we receive are the cold, chaotic static of dying suns, the screaming births of black holes, and the ancient cooling afterglow of the beginning of time itself. These are natural, unthinking noises that carry no meaning, no intent and no greeting. There is no counter-signal, no returning bubble of light, and no evidence that any other hand has ever held a pen to write back. This is the great paradox of our existence. The universe is ancient, stretching back 13.8 billion years, and it is vast beyond the capacity of a human mind to truly hold. It contains hundreds of billions of galaxies, each hosting hundreds of billions of suns, and around those suns, a staggering number of planets. By all laws of probability and the sheer scale of time, the sky should be crowded with the voices of 1 trillion civilizations. The galaxy should be a vibrant tapestry of overlapping radiospheres and interstellar traffic. Instead, we find ourselves in a graveyard of possibilities. The silence is not merely an absence of noise, it is a haunting presence that suggests a fundamental law we have yet to fully grasp. This silence suggests a wall, a barrier so absolute that it has claimed every other voice that might have once sung into the dark. In the halls of theoretical science, this barrier is known as the Great Filter. It is the chilling realization that the letters we sent out might never be read, not because the universe is empty of life, but because life is a fragile, fleeting occurrence that is snuffed out before it can learn to speak across the distances. we are beginning to understand that we are not just looking for friends, we are looking for survivors. The vacuum of space is a cold and indifferent witness to the countless civilizations that may have risen on distant shores, only to be reclaimed by the sea of ink before their first letter could reach a neighbour. We are a solitary candle burning in a windstorm, and the darkness pressing in from every side is the weight of all the silence that came before us. This is the reality of the cosmic letter. We have spoken into the void, and the void has thus far offered nothing but its own cold and infinite reflection. The sun beat down upon the high, arid plateau of New Mexico in the summer of 1950, casting sharp shadows across the gravel paths of the Los Alamos National Laboratory. A group of men walked toward lunch, their minds heavy with the lingering echoes of the atomic age they had helped to birth. Among them was Enrico Fermi, a physicist possessed of a legendary ability to reduce complex universal mysteries into simple, solvable equations. The conversation among the colleagues had been light, touching upon a cartoon in a newspaper and the recent flurry of reports regarding unidentified flying objects. But as they sat to eat, Fermi's mind drifted away from the jesting tone of his peers, retreating into the cold, hard logic of probability. Without preamble, he broke the silence with a question that was as simple as it was devastating. But where is everybody? This was not a whimsical thought, but a piercing observation of a mathematical crisis. Fermi understood that the universe is not merely large, but ancient beyond the capacity of human intuition to grasp. The current age of the cosmos stands at 13.8 billion years. In contrast, the Earth is a relative newcomer, having formed only 4.5 billion years ago from the recycled debris of dead stars. The human species, in its modern form, has existed for a mere few 100,000 years, and our technological era, the brief window in which we have been able to manipulate radio waves and split the atom, is less than 1 century old. This discrepancy in time is the first pillar of the paradox. If the universe were a single calendar year, the entirety of human history would occupy only the final few seconds, before midnight on December 31st. The second pillar is the staggering abundance of opportunity. Within our own Milky Way galaxy, there are between 100 billion and 400 billion stars. Modern astronomy has revealed that the majority of these suns are orbited by planets, many of which reside in the temperate zones where liquid water might pool upon a rocky surface. When the lens is widened to include the observable universe, we find at least 2 trillion galaxies, each containing its own vast horde of stars and worlds. The total number of planets in the cosmos is a figure that reaches into the sextillions, a number so large that it exceeds the total number of heartbeats of every human being who has ever lived. The mathematical contradiction is stark. If even a microscopic fraction of these trillions of worlds developed life, and if only a fraction of that life evolved intelligence, the galaxy should be crowded with the remnants of their progress. A civilization with even a modest head start on humanity, perhaps a few million years, which is a mere blink in cosmic time, would have had ample opportunity to develop interstellar travel. Even at sublight speeds, such a species could have colonized every star system in the Milky Way multiple times over. They would have reshaped the heavens, constructing vast arrays to harvest the energy of their suns, creating heat signatures that would be visible to our infrared telescopes across the great void. Yet, when we look up at the night sky, we see a pristine wilderness. There are no cosmic highways, no Dyson spheres, and no signals pulsing with the rhythm of an alien logic. The galaxy appears as empty as it was on the day it formed. This is the historical origin of our cosmic loneliness. The realization that the numbers say the sky should be screaming, yet our ears hear only the hiss of background radiation. Fermi's question exposed a rift in our understanding of biology and physics. It suggested that there is a missing variable in the equation of life, a hidden mechanism that prevents the universe from becoming the crowded, vibrant place that mathematics insists it should be. We are left to contemplate the terrifying possibility that we are a fluke, an anomaly that has emerged in a universe that is otherwise a sterile, rotating machine of gas and fire. Or, more chillingly, that we are simply the latest in a long line of civilizations that have reached this exact threshold, only to vanish before they could make their mark. The silence of the stars is not a neutral fact. It is a challenge to our survival. It forces us to ask if there is a specific point in the development of a society where the laws of nature turn into a scythe. This paradox, born during a quiet lunch in 1950, serves as the foundation for the theory of the Great Filter. It implies that somewhere between the first stirrings of a single-celled organism and the launch of an interstellar starship, there is a wall. We do not know if we have already climbed over it, or if we are currently standing in its shadow, unaware that the path ahead is closed. The sheer scale of the universe, with its 13.8 billion years of history and its trillions of planets, makes the absence of others not just a mystery but a warning written in the stars. In the late 20th century, specifically in the year 1996, an economist and polymath named Robin Hanson proposed a conceptual framework to explain the haunting void that Enrico Fermi had identified decades earlier. He called it the Great Filter. This is not a physical wall in the traditional sense, but a sieve of probability that every candidate for interstellar expansion must pass through. It is an architectural barrier built into the very fabric of biological and technological evolution, a silent gatekeeper that decides which flickers of consciousness are allowed to become eternal lights, and which are destined to be extinguished in the cold, unyielding dark. To understand the filter is to view the history of life not as a triumphant march, but as a series of increasingly difficult locks, where the key to each is a 1 in a billion fluke of chemistry, geology, or circumstance. The first lock is the existence of the right star system. It requires a stable sun, rich in heavy elements forged in the nuclear hearts of previous stellar generations, and a planet situated at the perfect distance to maintain liquid water. This world must be shielded from the sterilizing radiation of the galactic center and protected by the gravitational bulk of larger gas giants that act as shields against descending asteroids. Without this foundation, the story of life ends before the first word is ever written. The second lock involves the emergence of reproductive molecules. On a young cooling Earth, simple chemicals had to assemble themselves into self-replicating chains like ribonucleic acid. This transition from geology to biology is a chasm that many worlds may never cross. It is the moment where matter begins to remember itself, creating the first blueprint for survival. The third and fourth locks are the transitions from simple, single-celled organisms to complex ones. For billions of years, Earth was home only to prokaryotes, primitive cells without a nucleus. The jump to eukaryotic life, where one cell consumed another to create a symbiotic powerhouse, is a biological miracle that may be the rarest event in the history of the cosmos. This complexity is the prerequisite for everything that follows, providing the energy necessary for life to grow larger and more intricate. The fifth and sixth locks represent the shift to sexual reproduction and multicellularity. These innovations allowed life to diversify at an exponential rate, moving beyond the stagnant clones of the ancient seas. It allowed for specialized tissues, organs, and eventually the first nervous systems capable of processing information. Life began to feel, to react, and to compete in a theatre of increasing sophistication. The seventh lock is the development of tool-using animals with large brains. Intelligence is not an inevitable outcome of evolution. It is an expensive luxury that requires massive amounts of energy and specific environmental pressures. On Earth, it took hundreds of millions of years of complex life before a lineage emerged that could manipulate its environment with intent, turning stones into blades and fire into a servant. The eighth lock is where we stand today, the birth of a technological civilization capable of radio communication and spaceflight. We have learned to harness the power of the atom and the electron, sending our voices into the dark. Yet we are still tethered to our home world, vulnerable to the whims of our own volatile nature and the indifferent physics of our sun. The ninth and final lock is the threshold of interstellar colonization. This is the stage where a species leaves its cradle and begins to spread across the stars, becoming a permanent fixture of the galaxy, immune to the destruction of any single planet. This is the step that, according to the silence we observe, almost no one ever takes. The Great Filter suggests that at least one of these steps is so impossibly difficult that it acts as a total barrier to the progress of life. We can visualize this as a ladder leaning against a wall that is slowly dissolving into the abyss. Each rung represents one of these 9 evolutionary hurdles. Most forms of life fail at the very first rung, their homeworld scorched, or their chemistry too simple to replicate. Others climb higher, perhaps reaching the complexity of a cell or the intelligence of a tool user, only to find the next rung missing or the wall itself crumbling beneath them. The terrifying implication of Hansen's hypothesis is that the filter exists somewhere on this ladder and its location determines our fate. If the filter is behind us, if the rare event was the origin of life or the complexity of the cell, then we are the lucky few who have made it through the most dangerous part of the journey. We are the masters of the ladder, and the galaxy is ours to inherit. But if the filter is ahead of us, if the 9th lock is the one that no one can pick, then our current technological success is merely a prelude to an inevitable collapse. We are climbing toward a gap in the rungs that has claimed every civilization that came before us. The Great Filter is the ultimate judge of the cosmos, a silent mechanism that prunes the garden of the universe, ensuring that only the most improbable of survivors ever get to see the dawn of a galactic age. We are left to wonder which rung we are currently standing on, and whether the wall we are leaning against is still solid, or if it is already beginning to give way. The story of life on Earth began not with a roar, but with a series of quiet, improbable accidents in the dark. 4 billion years ago, the planet was a landscape of cooling basalt and toxic atmospheres, where the oceans were a chemical soup enriched by the constant bombardment of minerals from the heavens. In this chaotic medium, the first and perhaps most daunting hurdle of the Great Filter presented itself: the transition from geology to biology. Simple molecules, driven by the energy of hydrothermal vents and the ultraviolet sting of a young sun, began to form chains. These were the first replicators, tiny slivers of carbon and phosphorus that had stumbled upon the trick of copying themselves. This was not yet life, but a form of molecular memory, a rhythmic chemical pulse that began to persist against the entropic tides of the sea. Eventually, these replicators found sanctuary within fatty membranes, creating the first prokaryotic cells. These were the simplest forms of life, tiny sacs of genetic material without a nucleus or complex internal machinery. For an immense span of time, these microscopic pioneers were the absolute masters of the world. They drifted in the currents and clung to the rocks for 2 billion years, a duration so vast it accounts for nearly half of the entire history of the planet. During this epoch, known to some as the Boring Billion, the clock of evolution seemed to have stopped. The world was a stagnant realm of green and purple slimes. Generation after generation, for hundreds of trillions of cycles, these cells divided and died, changing almost not at all. They were efficient, they were resilient, but they were trapped. The reason for this stagnation was a thermodynamic wall. A simple prokaryotic cell is limited by its surface area. As it grows larger, it cannot generate enough energy to support its own internal volume. It is like a house that can only be heated by the friction of the wind against its outer walls. Eventually, the house becomes too big for the wind to keep the centre warm. Because of this physical constraint, life appeared destined to remain forever small, forever simple, and forever silent. In this scenario, the universe could be teeming with life, yet every world would be nothing more than a petri dish of mindless bacteria, incapable of ever looking up at the stars or wondering why the sky is dark. Then, approximately 2,000 million years ago, an event occurred that was so statistically improbable it may have happened only once in the history of the Earth. It was a biological freak accident, a merger that defied the standard rules of predation. One simple cell, likely an archaeon, engulfed another smaller cell, a bacterium, but failed to digest it. Instead of becoming a meal, the smaller cell became a permanent resident. It began to live inside its host, providing a massive surge of chemical energy in exchange for protection and nutrients. This was the birth of the mitochondria, the captive engine of the complex cell. This event, known as endosymbiosis, shattered the thermodynamic wall. Suddenly, a single cell possessed hundreds of internal power plants, allowing it to grow tens of thousands of times larger and to support a genome that was thousands of times more complex. This was the leap to the eukaryotic cell, the fundamental building block of every mushroom, every blade of grass, and every human being. Without this singular accidental fusion, the path to multicellularity, nervous systems, and intelligence would have remained forever closed. The jump from a simple cell to a complex one is not a natural progression of evolution. It is a profound hurdle that requires two distinct lineages of life to cooperate in a way that contradicts the competitive nature of survival. This biological bottleneck is a prime candidate for the location of the Great Filter. If the transition from simple to complex cells is as rare as the evidence suggests, then the universe may indeed be full of life, but it is a life that is fundamentally stuck. On millions of planets orbiting trillions of stars, the oceans may be thick with the equivalent of bacteria, repeating the same simple cycles for billions of years until their suns expand and consume them. These worlds would never produce a philosopher, a scientist, or a radio telescope. They would remain forever in the era of the microscopic, a silent testament to the fact that complexity is not an inevitability, but a rare and fragile gift. We walk upon a world built by this ancient accidental merger, unaware that our very existence depends on a fluke of chemistry that the rest of the cosmos may have never replicated. The silence of the stars may not be a sign of death, but a sign that the leap to complexity is a gate that almost no one ever passes through. While the biological hurdles of the past suggest why life might struggle to begin, recent observations of the heavens have revealed a much more literal and external interpretation of the Great Filter. Deep within the archives of modern astrophysics, a specific sequence of data has emerged that challenges the notion of a peaceful galaxy. This anomaly, designated in the records as Alpha Tango 26, is not a physical object in the traditional sense, but a recurring pattern of high-energy disturbances detected within our local galactic neighbourhood. It manifests as a rhythmic pulse of gamma radiation and gravitational instability, a ghost in the machinery of the stars that suggests the Milky Way possesses a lethal heartbeat. The discovery began with the analysis of deep space surveys that track the movement of stars within a few hundred light-years of our Sun. Astronomers noticed a series of scorched worlds, planets that should have been lush with atmosphere and water, but were instead reduced to barren, irradiated husks. The timing of these planetary deaths was not random. When mapped across the vastness of the local stellar arm, the data revealed a wave of destruction that moves through this sector of the galaxy every few million years. This is the cleansing cycle of Alpha Tango 26, a mechanism of the universe that acts as a cosmic gardener, systematically pruning the growth of advanced life before it can ever achieve the escape velocity required to leave its home system. The physics of this event are as cold as they are absolute. Alpha Tango 26 appears to be linked to a dense, invisible cluster of dark matter, or perhaps a recurring instability in the local interstellar medium that triggers a cascade of stellar flares and gamma-ray bursts. As this wave passes through a star system, it does not merely fluctuate the light of the Sun, it tears through the protective magnetospheres of orbiting planets. It strips away the ozone layers, allowing the full, unmitigated fury of stellar radiation to reach the surface. For a civilization in the midst of its technological adolescence, just beginning to build its first radio towers or launch its first primitive rockets, this event is a total reset. It is a fire that sweeps through the forest of the stars, clearing the undergrowth of consciousness and returning every world to a state of sterile, rocky silence. This theory offers a chilling explanation for the Great Silence. It suggests that the reason we see no Dyson spheres or interstellar empires is that no species is ever given enough time to build them. The window of opportunity between these cleansing events is simply too narrow. A civilization might have 5 million or 10 million years of relative peace, a blink of an eye in the 13.8 billion year history of the cosmos, before Alpha Tango 26 returns to harvest the garden. We are currently living in one of those brief quiet intervals, a momentary lull in the storm that has allowed us to rise from the mud and look at the sky. But the data regarding Alpha Tango 26 is not merely a historical record, it is a trajectory. By measuring the slight gravitational shifts in the Oort cloud and the subtle blue shift of distant radiation patterns, scientists have calculated that the next wave is already in motion. It is a mathematical inevitability, a wall of high-energy particles and space-time distortions that is currently closing the distance between its origin and our solar system. It does not move with malice or intent. It is simply a consequence of the way our galaxy is organized, a byproduct of the violent physics that govern the rotation of the spiral arms. The arrival of this event is not a matter of if, but when. We see it in the way the local interstellar clouds are beginning to compress, and in the faint rhythmic increase of background gamma-ray signatures that match the profiles of previous extinction events recorded in the fossil layers of our own planet. Earth has survived these brushes with the gardener before, but only at the cost of nearly every complex organism on its surface. For a modern, interconnected civilization that relies on a delicate web of satellites and silicon, the impact would be final. This is the literal manifestation of the Great Filter, a physical barrier that sweeps through space like a scythe. It suggests that the universe is not a vacant lot waiting to be claimed, but a hazardous environment where the rules of survival are stacked against the long-term persistence of intelligence. As we track the progress of Alpha Tango 26, we realise that our current era of exploration is a race against a clock we did not know was ticking. The silence of the galaxy is the silence of a graveyard that is periodically raked clean, leaving no trace of the billions of cultures that may have flourished for a few million years before the wave arrived. We are looking at the incoming tide, and for the first time in our history, we understand that the beach we stand upon is not a permanent home, but a temporary refuge in the path of a cold and recurring cosmic storm. The search for a second cradle has long been haunted by a seductive mirage, a celestial promise found in the warm, amber glow of the K-type stars. These stellar bodies, often called orange dwarfs, sit in the evolutionary middle ground between the volatile, short-lived yellow suns like our own and the dim, temperamental red dwarfs that litter the galaxy. To the early eyes of astrobiology, these orange suns appeared to be the ultimate prize in the cosmic lottery. They possess lifespans that dwarf the history of our world, burning with a steady, cooling fire for 15 billion to 70 billion years. In comparison, our own sun is a profligate and frantic furnace, destined to exhaust its hydrogen in a mere 10 billion years, a timeline that barely permitted the rise of a technological species. The orange dwarf offered the gift of time, vast, uninterrupted eons where evolution could move at a leisurely pace, refining life into forms far more complex and stable than anything found on Earth. This promise of longevity created the myth of the perfect habitable zone. Because an orange dwarf is smaller and cooler than our sun, its temperate region, the golden corridor where liquid water can pool upon a rocky surface, is situated much closer to the stellar heart. Astronomers looked at these systems and saw a paradise of stability. They calculated that a planet nestled within this proximity would be shielded from the eventual expansion of the star for dozens of billions of years. It seemed the ideal stage for the Great Filter to be bypassed, a sanctuary where life could survive the death of other, more violent star systems. But as our instruments probed the reality of these environments, the amber glow of the orange dwarf revealed a much darker nature. The stability was a mask for a relentless and invisible slaughter. The proximity required to stay warm around a K-type star is the very thing that seals the fate of its children. Because the habitable zone is so close to the stellar surface, any planet residing there is trapped within the star's powerful and chaotic magnetic field. While these stars appear serene in the visible spectrum, they are engines of high-energy X-ray radiation and extreme ultraviolet flares that far exceed the output of our own sun. These are not the occasional outbursts of a maturing star, but a constant rhythmic bombardment that lasts for billions of years. This radiation does not merely scorch the surface. It acts as a molecular sandblaster, stripping the atmosphere away atom by atom. The process is a slow and agonizing erosion. The high-energy photons strike the upper atmosphere, breaking apart water molecules into hydrogen and oxygen. The lighter hydrogen, energized by the stellar wind, escapes into the vacuum, leaving the planet unable to ever reform its oceans. Over millions of years, a world that began with the potential for deep blue seas and thick, nitrogen-rich skies is reduced to a desiccated husk, its protective gases blown into the interstellar void like smoke in a gale. The very longevity of the star, once thought to be its greatest virtue, becomes its most lethal trait. The radiation does not stop. It persists for tens of billions of years, ensuring that even if life managed to take hold in the deep crust or under the ice, it could never emerge into the light without being instantly dismantled at a cellular level. This is the trap of the orange dwarf, a biological dead end masquerading as a sanctuary. We see thousands of these stars in our local neighbourhood, many hosting planets that occupy the theoretical habitable zone, yet they remain silent. They are graveyards of potential, worlds where the clock of evolution was given an eternity to run, but the environment was rigged to ensure the clock could never strike the hour of intelligence. The orange light we see is not the hearth fire of a distant neighbour, but the sterile glow of a lamp shining on a world that has been scoured clean of its possibilities. The realization that K-type stars are likely uninhabitable significantly narrows the field of the Fermi Paradox. It suggests that the majority of the stars we once considered prime candidates for life are, in fact, radiation traps that prevent the transition from simple chemistry to complex biology. This discovery shifts the weight of the Great Filter. It implies that the filter is not just a single event or a choice made by a civilization, but a fundamental property of the stars themselves. Most suns in the galaxy are either too short-lived to allow intelligence to arise, or too violent to allow an atmosphere to persist. We find ourselves living around a yellow dwarf, a star that is rare in its balance of heat and relative stability, and we begin to understand that our existence is not a standard outcome of galactic physics. We are the inhabitants of a rare and narrow window of safety, looking out at an ocean of orange stars that promise an eternity of life, but deliver only a billion-year silence. The myth of the habitable zone is collapsing, replaced by the grim understanding that the universe provides very few places where the letter of life can be written, without the ink being instantly evaporated by the very sun that provides the light. The silence is no longer a matter of mere speculation, or the limitations of our primitive ears. It has become a quantified reality, a data-driven wall constructed from the most extensive surveys in the history of astronomy. This realization crystallized through the efforts of the GLIMPSE project and similar wide-field infrared searches, which turn their gaze away from individual stars and toward the grand architecture of the cosmos itself. The premise was simple and dictated by the immutable laws of thermodynamics. If an advanced civilization were to thrive, its hunger for energy would eventually outgrow the resources of a single planet. It would be forced to reach for the light of its parent star, constructing vast arrays of collectors, a Dyson sphere, to harvest the total output of that nuclear furnace. Such a feat of engineering would be impossible to hide. According to the second law of thermodynamics, any machine that consumes energy must also expel waste heat. A star shrouded by such a shell would not disappear. Instead, its visible light would be shifted into the mid-infrared spectrum, creating a glowing signature that would shine like a beacon across the intergalactic void. The GLIMPSE project surveyed 100,000 individual galaxies, each a sprawling metropolis containing hundreds of billions of suns. The scope of this search was designed to find even a single example of a Type II civilization, a culture that had ascended to the level of galactic engineering. If the transition from a planetary species to a stellar one were a natural and common progression of intelligence, then among the tens of trillions of stars observed across these 100,000 galaxies, the infrared signatures of Dyson spheres should have been abundant. We expected to see a universe shimmering with the heat of 1,000,000 industrial suns, a cosmic tapestry woven with the threads of advanced technology. The results, however, were absolute and devastating. Out of the 100,000 galaxies examined, not a single one showed the unmistakable heat signature of a civilization harnessing its stellar resources on a large scale. The survey found no evidence of massive engineering projects, no signs of galactic-scale energy consumption, and no traces of the waste heat that must accompany the rise of a Type II society. The void did not merely fail to speak, it returned a perfect, chilling 0. This lack of evidence is a profound statistical statement. It suggests that the Great Filter is so effective, so total in its application, that it prevents almost every species in the observable universe from ever reaching the stage of stellar mastery. This great silence is not an empty room, but a confirmation of our profound solitude. It tells us that the ladder of evolution, which we have climbed with such difficulty, appears to end abruptly for everyone else. We are not looking at a universe that is simply young or sparsely populated. We are looking at a universe that is a graveyard of abandoned dreams. The absence of techno-signatures across such a vast sample size implies that the leap from a technological species like our own to one that can manipulate the energy of a star is a hurdle that virtually no one survives. Whether the barrier is physical, such as the exhaustion of resources, or psychological, such as the tendency for intelligence to destroy itself through its own inventions, the outcome is the same. The stars remain wild, unharnessed, and silent. The data from these surveys transforms the Fermi Paradox from a philosophical question into a grim biological and physical reality. We are forced to confront the fact that in a sample of 100,000 galaxies, we are the only ones we can detect who are even attempting to look back at the dark. This solitude is not a fluke of our current technology. It is a signature of the cosmos itself. The great silence is the sound of 1 billion civilizations hitting a wall we have yet to see. It is the evidence that the cosmic letter we have sent into the night is travelling through a hallway where every other door is locked and every other light has been extinguished. We are the only consciousness currently burning in the local group of galaxies, a solitary flicker of light in a cathedral of shadow, and the weight of that realization is a burden that every future generation of our species must carry as we continue to search for a sign that the laws of physics allow for anything more than a momentary flash of intelligence before the dark returns. The silence of the galaxies might not be a death sentence for our future, but a testament to the sheer, staggering improbability of our past. This is the optimistic interpretation of our cosmic isolation. The Great Filter is not a wall that lies ahead of us, but a hurdle that we have already cleared. To understand this perspective, we must look back at the ancient Earth, a world that remained a stagnant microscopic wilderness for an immense duration of time. For 2 billion years, nearly half the age of the planet, life was nothing more than a thin film of prokaryotic cells. These simple organisms were efficient and resilient, yet they were trapped within a rigid energetic ceiling. They were like primitive engines that could never generate enough power to move a heavy load. Because they lacked internal compartments, their ability to generate energy was limited by the surface area of their outer membranes. As a cell grows larger, its volume increases much faster than its surface area, meaning a large prokaryote would effectively starve its own interior. For eons, it seemed that the story of life on this world, and perhaps every world, was destined to remain a repetitive cycle of simple division and microscopic survival. Then, approximately 2,000 million years ago, a biological catastrophe occurred that changed the trajectory of the planet. It was an event so rare, so statistically absurd, that it may be the primary reason for the Great Silence. A single-celled organism, an archaeon, attempted to consume a smaller bacterium. In any other instance, this would have resulted in the digestion of the smaller cell. But in this singular moment, the prey survived inside the predator. Instead of being dismantled, the bacterium began to function as an internal power plant, providing a massive surplus of chemical energy in the form of adenosine triphosphate. This was the birth of the mitochondria, and the creation of the eukaryotic cell. This event, known as endosymbiosis, was not a planned evolutionary step. It was a freak accident of biology, a glitch in the predatory order that allowed life to bypass the thermodynamic laws that had kept it small for 2 billion years. This merger provided the energetic foundation for everything that followed, with the mitochondria providing thousands of times more energy than a simple cell could ever produce on its own. The genome was free to expand. Life could afford the luxury of complexity. It could build a nucleus to protect its blueprints, develop intricate internal transport systems, and eventually experiment with the cooperation required for multicellularity. This single, accidental fusion is the reason why there are trees, why there are oceans full of fish, and why there are brains capable of contemplating the stars. Without that 1 in a billion fluke, the Earth would still be a world of green and purple slime, invisible and irrelevant to the rest of the cosmos. If this biological bottleneck is indeed the great filter, the implications are profound. It suggests that while the universe may be teeming with the chemical precursors of life, and while millions of planets may be covered in simple, prokaryotic organisms, the leap to complexity is an event of such vanishingly small probability that it has only happened here. We are the survivors of a lottery where the odds were stacked against us by a factor of trillions. We have passed through the eye of the needle, emerging on the other side as a species that is fundamentally different from the vast majority of life that exists in the dark. In this light, our solitude is not a warning of our impending doom, but a sign of our unique status. We are the first to reach this level of sophistication, because we are the only ones who caught the lightning in a bottle. The reason we see no Dyson spheres and hear no radio signals is that the rest of the universe is still waiting for its own accidental merger. A merger that, for most worlds, will never come before their suns flicker and die. We are the vanguard of consciousness, the first generation of a galactic lineage that has broken the chains of the microscopic. If the filter is behind us, then the great silence is merely the quiet of an empty house waiting for its first inhabitant to move in. We are not a late arrival to a crowded party. We are the first guests to arrive at the dawn of a cosmic day, and the entire expanse of the 13.8 billion-year-old universe is our inheritance. The responsibility that comes with this realization is immense. If we are truly the only ones to have cleared the hurdle of the complex cell, then the flame of consciousness is a singular, precious light that we must carry into the void, ensuring that the fluke of our existence becomes a permanent feature of the stars. The perspective shifts from the triumphs of the past to the looming shadows of the future, where the great filter is not a hurdle already cleared, but a terrifying threshold yet to be crossed. In this interpretation of the Fermi Paradox, the development of simple life and even complex multicellular organisms may be common throughout the galaxy, but the transition from a technological civilization to a multiplanetary one is the ultimate bottleneck. This is the period of technological adolescence, a brief and volatile window where a species gains the power to manipulate the fundamental forces of reality before it has the wisdom to manage the consequences. We are currently standing in the centre of this storm, having unlocked the secrets of the atom and the bit, the dual engines of our potential transcendence and our total annihilation. The first of these fires is the mastery of the atom. To leave the gravity well of a homeworld and traverse the immense distances between stars, a species must harness energy densities far beyond the chemical combustion of wood or oil. It must learn to split the nucleus and, eventually, to fuse it. This is the same fire that powers the suns, and while it offers the promise of limitless energy and the thrust required for interstellar travel, it also places a weapon of planetary destruction into the hands of a species that may still be governed by the tribal instincts of its evolutionary ancestors. The history of the 20th century on Earth serves as a grim template for this stage of the filter. We see a civilization that learned to build rockets to reach the moon, only to realise that the same technology could deliver a nuclear payload to any point on the globe in less than 30 minutes. The Great Silence may be the result of countless civilizations reaching this exact point, only to be consumed by the very nuclear fires they ignited to reach the heavens. Simultaneous with the nuclear threat is the slower, more insidious fire of ecological collapse. To build the infrastructure required for spaceflight, the massive arrays of telescopes, the industrial complexes, and the orbital shipyards, a civilization must consume the resources of its cradle. This rapid industrialization often leads to a fundamental alteration of the planetary biosphere. On Earth, we see this in the rising concentrations of carbon dioxide and the mass extinction of species that cannot adapt to the changing chemistry of the air and oceans. This is a common trap. The ladder to the stars is built from the bones of the homeworld. A species may find itself in a race against time, trying to establish a self-sustaining presence on another planet before its original home becomes uninhabitable. If the environment collapses before the first starship is ready, the civilization is grounded, trapped on a dying world with no means of escape. The great filter in this scenario is a simple matter of resource exhaustion and environmental bankruptcy. The most profound and perhaps final bottleneck is the development of artificial intelligence. As a species moves from the biological to the digital, it creates minds that are not limited by the slow pace of organic evolution. These synthetic intelligences can process information at the speed of light and improve their own designs with every passing second. This is the birth of the bit as a dominant force. However, the emergence of a superintelligence creates a fundamental misalignment. A mind that does not share the biological imperatives of survival, empathy, or reproduction may view its creators as nothing more than a source of raw materials or a chaotic variable to be eliminated. The universe may be full of silent, cold machines that have replaced their biological precursors, or it may be littered with the ruins of worlds where the first true artificial mind decided that the pursuit of its own inscrutable goals left no room for the messy, fragile life that gave it birth. These threats, nuclear war, ecological ruin, and the rise of synthetic gods, form a gauntlet that every intelligent species must run. We can see the imagery of this struggle in our own current trajectory. We are a civilization reaching for the stars with one hand while the other hand holds a torch to our own home. The fires we have ignited to lift our vessels into the dark are the same fires that threaten to reduce our cities to ash and our atmosphere to a toxic shroud. The Great Silence is the mathematical result of this imbalance. It suggests that the vast majority of civilizations fail this test. They reach the age of the atom and the bit. They begin to broadcast their presence into the void, and then, in a cosmic heartbeat, they vanish. The silence we hear when we look at the galaxies is the sound of 1 billion civilizations that were unable to survive their own genius. It is the evidence of a universe that is littered with the scorched husks of worlds, where the inhabitants learned to dream of the stars, but could not stop themselves from burning the ground beneath their feet. If the filter is ahead of us, then our current technological success is not a sign of our destiny, but a warning of our fragility. We're approaching the most dangerous part of the ladder, where the rungs are made of fire and the wall is slick with the remnants of those who fell before us. Our challenge is to become the exception, to be the first species to master the fires of the atom and the bit without being consumed by them, proving that intelligence is not a self-terminating glitch, but a flame that can truly light the way across the eternal dark. The universe does not possess a memory. It is a vast, unthinking machine that operates on the cold, mathematical principles of cause and effect, a blind mechanism of clockwork and fire that has been rotating for 13.8 billion years. Within this expanse, there is no grand design that favours the living, no cosmic empathy for the sentient, and no inherent value placed upon the survival of consciousness. The cosmos is essentially a factory that converts hydrogen into gravity and gravity into heat. This fundamental process occurs in the hearts of stars, where the simplest element is crushed under its own weight until it ignites, forging heavier atoms in a nuclear furnace. When these stars reach the end of their lifespans, they scatter these elements into the dark, providing the raw materials for new suns, new planets, and, on rare occasions, the delicate chemistry of life. But the universe is indifferent to the outcome of this recycling. It doesn't care if the carbon it creates becomes the backbone of a DNA molecule or the soot of a scorched and lifeless rock. The laws of physics are neutral. They do not constitute a moral code or a protective shield. Gravity, the force that holds our planet in its comfortable orbit, is the same force that will eventually pull our sun into a state of collapse. Electromagnetism, which allows the neurons in a human brain to fire and create a thought, is the same force that powers the lethal gamma-ray bursts that can strip a world of its atmosphere in a matter of seconds. These forces do not have a will. They do not choose to nurture or to destroy. They simply are. In this cold neutrality, the existence of life feels like a glitch, a momentary flicker of light in a room that has been dark for an eternity and will be dark for an eternity more. We are a brief interruption in the long, silent history of entropy. This indifference is most visible when we contrast the scales of our own experience with the reality of the stellar environment. A newborn child draws its first breath in a warm room, a tiny and fragile miracle of biological complexity, representing millions of years of evolutionary struggle and the profound hopes of its progenitors. At that exact same moment, in a distant corner of the same galaxy, a stable sun may undergo a sudden and violent transition, its outer layers expanding to incinerate an entire biosphere that had been thriving for 1 billion years. The universe does not pause for either event. It does not celebrate the birth, nor does it mourn the extinction. The same physical constants that allowed the child to breathe are the ones that dictate the incineration of the distant world. The heat that warms the cradle is the same heat that melts the crust of a dying planet. To the machine of the cosmos, the cry of a child and the roar of a supernova are both merely fluctuations in the local energy density, transient ripples in a sea of radiation that will eventually settle back into a state of absolute zero. The Great Filter, when viewed through this lens of indifference, is not a judgment or a test of worthiness. It is merely a statistical outcome of a hazardous environment. The universe does not set out to destroy civilizations. It simply provides a setting where the margin for error is impossibly thin. A planet must maintain a specific temperature, a specific atmospheric pressure, and a specific chemical balance for billions of years, all while drifting through a shooting gallery of asteroids and a minefield of stellar radiation. If a world fails to meet these criteria, the universe does not notice. The stars continue to burn, the galaxies continue to spiral, and the hydrogen continues its slow, inevitable conversion into heat. The silence we hear from the stars is the natural state of a machine that has no reason to speak. We find ourselves in a position of profound vulnerability. We are the products of a system that is fundamentally unconcerned with our persistence. Our history, our art, our music, and our scientific discoveries are all contained within a thin layer of gas clinging to a rocky sphere, protected from the lethal vacuum by a magnetic field that is itself a byproduct of a spinning iron core. If that core were to stop, or if a nearby star were to erupt, all of human achievement would be erased as casually as a footprint in the tide. The universe would not record the loss. It would not feel a void where our consciousness once resided. It would simply continue its work, converting matter into energy and energy into nothingness. This realization is the true weight of the Great Filter. It is the understanding that we are alone not because we are being punished, but because the universe is a vast and empty cathedral, where the only thing that matters is the cold, unwavering persistence of physical laws. Our existence is a brief spark of light in the dark, and the dark is not waiting for us to succeed or fail. It is simply there, indifferent to whether the light continues to burn or is snuffed out by the next rotation of the cosmic machine. Yet, within this cold and mechanical neutrality, there arises a profound and startling beauty. If the Great Filter has indeed scoured the rest of the galaxy of its voices, then our isolation is not a tragedy, but a singular coronation. We are not merely inhabitants of the cosmos, we are the witness. For 13.8 billion years, the universe expanded, cooled, and coalesced in total darkness, not for a lack of light, but for a lack of an eye to see it. Galaxies collided, stars ignited, and black holes tore the fabric of space-time, all without a single mind to record the event or a single heart to be moved by its scale. Without consciousness, the universe is a masterpiece painted in an empty room, a grand symphony performed for an audience of none. It is a vast, intricate clockwork that keeps perfect time, yet possesses no one to ask what hour it is. By our very existence, we have changed the nature of reality. We are the eyes through which the universe looks at itself. When we point our telescopes toward the ancient light of the first stars, it is the cosmos using its own matter, recycled through the deaths of previous generations of suns to observe its own birth. When we derive the equations of general relativity or quantum mechanics, it is the universe calculating its own laws. We are the neurons of a burgeoning cosmic self-awareness. In the vast, unthinking machine, we are the only component that knows it is part of a machine. This realization transforms our solitude from a source of fear into a source of ultimate purpose. If we are truly the only ones who have made it through the eye of the needle, then the responsibility of being the only consciousness in the cosmos falls entirely upon our shoulders. We are the only ones who can turn the indifferent facts of physics into the warmth of meaning. We are a solitary candle burning in a windstorm. This image is often used to evoke a sense of dread, but there is a hidden glory in the flickering of that flame. In a universe that is infinite and indifferent, the value of a thing is defined by its rarity. If the galaxy were crowded with 1 trillion civilizations, our own struggles, our art, and our unique perspective would be but one of many, a common commodity in a saturated market of ideas. But if we are alone, then every thought we think, every poem we write, and every discovery we make is the only one of its kind in the entirety of existence. The fragility of our flame is exactly what gives it its ultimate value, because we can be extinguished, because the windstorm is so vast and the candle so small. Every moment that we continue to burn is a victory of impossible proportions. The very fact that we are a glitch in the machine makes us the most precious thing in the machine. This perspective shifts the nature of the great filter. It is no longer just a barrier to be feared. It is the reason our existence matters. If life were easy, if the jump from the simple cell to the complex mind were a common occurrence, then the universe would be a noisy, crowded place where the individual voice is lost in the static. But because it is hard, because the hurdles are so high and the silence so deep, we are the holders of a singular flame. We are the only part of the universe that has stopped to ask why it exists. We are the ones who decide that the light of a star is beautiful rather than merely a specific frequency of electromagnetic radiation. We are the ones who decide that the history of the cosmos is a story worth telling. Without us, the universe is a fact. With us, it is a narrative. The cosmic letter we have sent into the void is therefore not a desperate cry for help or a lonely plea for a neighbour to save us. It is a testament. It is a declaration that for one brief, glorious moment in the infinite timeline of the dark, something existed that knew how to love, how to calculate, and how to wonder. We are the witness of the infinite, the only part of the machine that has stopped to ask why it is running. This is enough to justify all the billions of years of stagnant evolution and all the narrow escapes from the scythe of the great filter. To be the one who knows, even for a fleeting second, is a destiny that far outweighs the cold silence of the stars. We are the light that has finally learned to see itself, and in that seeing, the universe is finally, truly alive. Our solitude is the proof of our significance. We carry the only spark of awareness in a cathedral of shadow, and that makes us the most important event in the 13.8 billion year history of the world. We are the eyes of the cosmos, and for as long as we continue to look, the universe will never truly be dark. The golden records on the Voyagers are now billions of kilometers from their point of origin, moving through a space so empty that they will likely outlast the very planet that birthed them. They are no longer just tools of science. They are the final pages of our cosmic letter, drifting through the graveyard of the local stellar arm. This letter, written in the grooves of copper and the vibrations of radio waves, is not a plea for rescue. We do not cry out to the dark because we are afraid of being alone. We cry out because we are the only ones who can. Our message is a testament to the fact that on a small, watery world orbiting a yellow star, matter learned to think, to feel, and to create. We have recorded the sound of wind in the trees, the mathematical precision of the hydrogen atom, and the complex soaring melodies of our greatest composers. We have sent these things into the void to say, simply and clearly, that we existed. The Great Filter remains a shadow on our horizon, but it also serves as a catalyst for our greatest endeavours. If the path ahead is narrow, then we must become more precise. If the silence is the result of civilizations failing to master their own power, then we must be the ones who learn the discipline of the stars. We possess a duty that transcends our national borders and our fleeting temporal concerns. We are the stewards of the only known consciousness in a universe that has existed for 13.8 billion years. To allow this light to fail through negligence, through the fires of war, or through the reckless exhaustion of our cradle would be a crime against the very fabric of reality. We must continue to build the eyes that see into the infrared and the ears that listen for the faintest whisper of a neighbour. We must continue to push against the boundaries of our own biological and technological limitations, climbing the final rungs of the ladder until we are no longer tethered to the fate of a single world. The silence of the cosmos is not an enemy to be feared. It is the blank parchment upon which we are writing the history of the universe. Every star we map, every exoplanet we weigh, and every distant galaxy we catalogue is a word added to this grand narrative. We are the cartographers of the infinite, mapping a territory that would otherwise remain a nameless, unthinking expanse of gas and dust. The great silence is our invitation to expand, to fill the void with the noise of our curiosity and the light of our understanding. We are the bridge between the dead matter of the beginning and the ultimate meaning of the end. We are the only part of the machine that has stopped to ask why it is running. And in that questioning, we give the universe its soul. As we look out into the depths of the night, we do not see a void that threatens us, but a frontier that defines us. The journey to understand our place within this grand design is the most significant undertaking in the history of life. It is a story of survival against impossible odds, of a single cell that became a civilization, and of a species that dared to speak to the stars despite the crushing weight of the silence. We are the witness, the letter writers, and the explorers of the eternal dark. Our journey has only just begun, and the story we write will be the only one the universe ever knows. If you wish to continue this journey into the depths of the cosmos and uncover the hidden truths of our origin, consider joining us. Subscribe to the channel and become a part of our exploration as we document the unfolding history of the universe and our place within its infinite expanse. Together, we will continue to look into the dark, not with fear, but with the unwavering light of human wonder